Lesson 2.2, video part 2. Solve the system by substitution. So unlike the last two examples we had looked at, where one of the equations was already solved for y, we have two equations now where neither of them is solved for a variable. Now here's again where we want to be efficient and strategic. So if we look at all the variables here, we have a variable there which has a 7 attached to it. We have a y that's right there that's negative. We have an x right there that's negative, and we have a y right here that is positive. Of those four, the y that's positive would be the simplest to solve for. So let's do that. I'm going to take this equation and solve for y. By adding x to both sides, I get y equals x minus 7. And that is our equation that we will use to plug into the other equation. Now this one's gone. We've modified it so it's solved for a variable. That y value will then be plugged into the other equation, which will give us 7x minus, and our y is now modified to x minus 7 equals 1. Now we have one equation with one variable, meaning they're all x's, so we combine like terms. Now this is a negative 1, so we'll have to distribute that, which will give us 7x minus 1 times x is a minus x, minus 1 times negative 7 is a positive 7, equals 1. These two are like terms. 7 minus 1 is 6. We subtract 7 to solve for x. We get negative 6, divide by a 6, and x equals negative 1. And again, we're looking for a coordinate, and we just found the x value. That x value can then be plugged into either one of these two equations. Again, all about efficiency and being strategic. Fewer steps, fewer chances of error. So let's not do that one. Let's plug it into this one, which would give us y equals negative 1 minus 7, y equals negative 8. So our solution to the system is negative 1, negative 8. Let's try another one. Example 4, same situation. We have two equations, neither of them are solved for a variable. Again, let's look at efficiency. Here we have an x that's by itself and it's positive. Here we have a y that's with a negative 6 attached to it, an x with a 5 attached to it, and a y with an 8 attached to it. Definitely the x that has a positive 1 out front would be the easiest to solve. So let's do so. We're going to take this equation and modify it. We're going to add 6y to both sides. And that will give us x equals 6y minus 20. Now in the past we've been solving for y, so it's okay to solve for x sometimes. We're just trying to be efficient here. But this is the value that we're going to substitute into the next equation for x. Again, in the past we've been solving for y and substitute that in, but we can do whatever variable works easiest. But do remember that we have solved for x, which means we now must solve or substitute in 6y minus 20 into the x position, which gives us 5 times the new x, that is 6y minus 20, plus 8y equals negative 24. Again, this equation doesn't exist anymore, we've modified it. So we distribute, and we get 30y minus 100 plus 8y equals negative 24. These two are like terms, and we get 38y minus 100 equals negative 24. We will add 100 to both sides, and we will get go up here now, 38y equals 76 divided by 38, and y is equal to 2. Again, we're looking for a coordinate, and we just found the y value. Remember that that is the y, not the x. So we'll take that value and we will substitute into either of the two equations. We can plug it in here or here, but again, for efficiency's sake, it would work out best to plug it into our modified equation. And we will get x equals 6 times the new y value, which is 2, minus 20. So x is equal to 12 minus 20. So x will equal a negative 8. And that is our coordinate, negative 8, 2. And this ends video 2.